Hi friends, in the last lecture we read about the various developments that led to the formulation of Bohr's model of hydrogen atom. So in this lecture we shall see the various features of Bohr's model and also its limitations. So let's start with the topic. Niels Bohr was the first to explain the general features of the structure of hydrogen atom and its spectrum. He used Planck's quantum theory for this. So let's see the postulates of Bohr's model. First, electrons move around nucleus in circular paths of fixed radius and energy. These circular paths are called orbits or energy levels. So he coined a new term, that is orbits. Second, an electron can move only in those orbits for which the angular momentum is integral multiple of h by 2 pi. So he gave this new formula that electron can move only in those orbits in which the angular momentum is the integral multiple of h by 2 pi, in which h is Planck's constant and pi, you know that it's 22 by 7. So basically he said that the value of h by 2 pi must be some integer such as 1, 2, 3. It cannot be in decimals or in fractions. Otherwise the orbit will not be possible. And the last postulate was that energy of an electron in an orbit will not change with time. But when the electron will move from a lower orbit, a lower energy level to higher energy level, then energy will be absorbed. And when it will move from higher energy level to lower energy level, then energy will be emitted. So basically in this way, he successfully explained the stability of atom. So he explained that why an atom will not fall into the nucleus. This is because while moving in a certain orbit, electron does not emit any energy. It only emits or absorbs energy when it shifts from one orbit to another. So let's understand Bohr's theory for hydrogen atom. First, the orbits for electrons are numbered n is equals to 1, 2, 3 and so on. These integral numbers are called principal quantum numbers. We shall deal with principal quantum numbers again in the 5th and 6th lectures. Second, radii of orbits can be expressed as Rn is equals to n square a naught, in which Rn is called the radius of that orbit and n square is, again as I told you that the orbits are numbered 1, 2, 3. So n square is that number, that orbit number, and a naught is 52.9 picometer. So putting these three values, we can find that radius of first orbit, that is R1, will become 1 square into 52.9, that is 52.9 picometer. And similarly, we can calculate the values for radius of second, third and fourth orbits by putting the values of n as 2, 3 and 4. And it also said that energy of the orbit, that is En, is equals to RH multiplied by 1 upon n square, in which RH is Heisenbergs constant and its value is 2.18 into 10 raised to power minus 18 joules. So by applying this formula, that is RH, that is Heisenbergs constant, multiplied by 1 upon n square, we can find the value of energy of that orbit. Thus, putting the values of n as 1, we can find the energy of first orbit as minus 2.18 into 10 raised to power minus 18 into 1 upon 1 square. That becomes minus 2.18 into 10 raised to power minus 18 joules. So there were two major achievements of Bohr's model. First, he successfully explained what Rutherford's model could not do. So as I have told you in the previous lecture that Rutherford's model could not explain the stability of atom, also it could not explain the line spectra of hydrogen atom. So all these things were successfully explained by Bohr's model. But again, Bohr's model had many limitations. It was not able to explain the Zeeman effect, the Stark effect, and the formulation of chemical bonds. So Zeeman effect is the splitting of spectral line in the presence of magnetic field. And Stark effect is the splitting of spectral lines in the presence of electric field. So all these things could not be explained by Bohr's model. And also he failed to explain the ability of atoms to form molecules by chemical bonding. So due to these limitations, we can say that Bohr's model of atom has failed. So now what is the next model of atom? That is the quantum mechanical model of atom. So let's see the developments leading to the quantum mechanical model of atom. These were dual behavior of matter and Heisenberg's uncertainty principle. So let's study both of them in detail. First, dual behavior of matter. In 1924, French physicist de Broglie proposed that matter-like radiation should also exhibit dual behavior. So basically, just like electromagnetic radiation shows dual behavior, similarly, matter should also show dual behavior. It should act both as a wave and particle. This means that even electrons should behave both like wave as well as like particle. This was stated by French physicist de Broglie. This property was used for making electron microscope, and also it played a major role in the development of quantum mechanical model of atom. And the second development that led to the formulation of quantum mechanical model of atom was Heisenberg's uncertainty principle. So basically, in 1927, Werner Heisenberg stated that it is impossible to determine the exact position and velocity of an electron. It rules out the existence of definite paths or orbits of electrons. So Bohr's model was proved wrong by this principle. So basically, Heisenberg's uncertainty principle says that we cannot define a definite path or orbit for electrons. It is only possible to predict the probable region in a given space where we can find the electron. So we cannot definitely say that the electron will be present in this orbit. We can just predict that it will be probably in this orbit. Thus, Heisenberg replaced the concept of definite orbits by the concept of probability. So this concept of probability is very important for the formulation of the quantum mechanical model. This paved the path for quantum mechanical model of atom. So this was all for today. In the next lecture, we shall discuss the quantum mechanical model of atom. So stay tuned.